start with a new chapter, which is cube and cube roots. So we all know about squares and we all know about square roots, right? So if I'm saying x square, right, what does this mean? It means that x is multiplied by itself for 2 times, right? Now, if I'm talking about root of x square, what does it mean? It means whatever number is squared, whatever number is multiplied by itself gives us x square. We have to write it down here, which is x, right? So what is cubes and what is the root of a cube root of a number, right? So a cube means if we are multiplying a number by itself for 3 times, that is called a cube of a number, right? Now, cube roots are when we are finding the original number when a perfect cube is given, right? So let's start with the chapter cube and cube roots. So what is cube of a number? A number multiplied by itself for 3 times is known as the cube of a number. This is 3 times the number itself, right? That means if there is a 4, right? We have seen cubes, right? So when we are talking about cubes, we have, when we are considering the volume of a solid figure, we say that it's length into breadth into height, right? So here we have a cube having the base as 4, width as 4 and depth as 4, right? Length, breadth and height as 4. So this is a cube. We all have seen Rubik's cubes, right? So Rubik's cubes are a very good example for a cube. And now when we are finding the volume of a cube, what do? We find out one side of the cube, we multiply it by itself for 2 more times, right? So what do we have? 4 into 4 into 4. So 4 4 is 16. 16 into 4 would be equal to 16 into 4 is 6 4 is 24. 4 1s are 4 and 5 6. We have 64 as the answer for 4 cube. It's represented by having the radical as 3, right? Now let's move on to perfect cubes. So what are perfect squares in the first place? So when we take a number, we multiply it by another number and we get a whole number. That number is called the perfect square. Now in the same way, a perfect cube is when we take a number, we multiply it by itself for 3 times and we get a final result. Now that number is called a perfect cube. We could see some perfect cube over here. We have 1 cube to be 1, 2 cubes to be 8, 3 cube to be 27, 4 cube is 64, etc. is given, right? So these numbers, 8 which is 2 into 2 into 2, 3 which is 3 into 3 into 3, 64 which is 4 into 4 into 4, and 125 which is 5 into 5 into 5 are known as perfect squares, right? So let's talk about how to find the cube, how to find the smallest multiple that is a perfect cube, right? So what do we have to find? We have to find the smallest multiple that is a perfect cube, right? So how do we do this, right? Now express the given number as a product of prime numbers and group them into 3. Remember when we are doing the prime factorization method to find the square root of a number, we would find the prime factors and group them into 2, right? Now if any factor is not appeared in such grouping, then that is the amount, the product of all these numbers would be the smallest multiple for making a number a perfect cube. Let's say for example, we have 3600 here, right? So we have 3600, right? Now we prime factorize it. So we have 2 times divided by 2, we have 1 and 6, we have 8, we have 0 0, right? Now again by 2 we'll get 900, again by 2 we are going to get 450, again by 2 we'll get 2 2s are 4 and 1 0 which is 5. Now is it divisible by 3? How do we see the divisibility for 3? We add all these digits, that is 2 plus 2 plus 5. which is 5 plus 9, 5 plus 4, which is equal to 9. So that number is divisible by 3, so we'll divide it by 3. We have 7 threes are 21 and 5 threes are 15. So we got 75. Now let's see whether 75 is actually divisible by 3. So 7 plus 5 is equal to 12 and 12 is a multiple of 3. So we could again divide it by 3. Now 2 3s is 6 and 1 5, we have 25. Now we have 25 here, prime factorizing it. So is it divisible by 3? No, it's not. Now what is the next prime number which is divisible in 25? We have 5 here, right? The last digit is 5. So we have 5 into 5 is equal to 25. Now 1 times 5 is equal to 5 and we reached 1. When we reach 1, we stop the factorization and let's see. We have a triplet of 2. We are grouping every number which have 3 together. Now this would have been a triplet, but when? If we have 2 more 2's, right? 2 into 2 into 2 would be a triplet, right? Now we have 2 3's here. This would have been a triplet when if we have 3 here. This into 3 would make it a triplet. That would make it a group of 3, right? Now here too we have 2 5's and if we had one more 5, it would have been a triplet, right? So what are the numbers when multiplied to these prime factors would give us a perfect square? So if we have 2 into 2 into 3 into 5, right? Now we know that 5 3s are 15. 15 into 2 is equal to 30 and 30 into 2 is equal to 60, right? The smallest multiple for making 3600 a perfect cube would be 60 here, right? Yeah. Now let's move on and check up on some various properties of cube numbers, right? First of all, cubes of all even natural numbers are even. Now let's go back to this area and see the cubes of all even natural numbers. Now we have 2, we have 8 as the cube, 4 cube is 64, 6 cube is 216, 8 cube is 512 and it just goes on. And how is this happening? Right? So when we are multiplying an even number of times, no matter how many times it is, it would turn out to be an even number, right? Now, cubes of all odd numbers are odd. In the same way, when multiplying an odd number by an odd number, we would continue getting odd numbers every single time, right? Now, the sum of the cubes of n natural number is equal to the square of their sum. Now, what does this mean? If we have 1 cube plus 2 cube plus 3 cube, let me say up to 4 cube, right? Here we are taking it till n cube. They are saying that this would be equal to 1 plus 2 plus 3 plus 4 the whole square. Now let's see, 1 cube is 1, 2 cube is 8, 3 cube is 27 and 4 cube is 16 into 4, which gives us 4 cube is, we have 64. So 64. Now let's add this. We have 8 plus 1 is 9, right? So we have 9 plus 27 plus 64. Now we have 7 plus 9 is equal to 16. 16 plus 4 is equal to 20. We have 2 balance. 2 plus 2 is 4 and 4 plus 6 is 110. So the answer would be 100. Here the left hand side is equal to 100. Now let's check with the right hand side. The right hand side would be equal to 4 plus 3 is equal to 7. 7 plus 2 is 9 and 9 plus 1 is 10 and 10 square is equal to 100. So here we get this equation that 1 cube plus 2 cube plus 3 cube up to n cube, up to any number, if we add the cube of individual numbers to each other, that would be equal to the sum of all numbers square, right? Now, cubes of number ending in digit 2 ends in digit 8 and vice versa. So, if you look at this chart very carefully, we could see that the number which have 2 in the units place have the cube ending with 8. Now, let's see, about 12, we have an 8 in the ones place. Again, in the case of 22, we have 8 in the ones place. Now, let's check the vice versa situation. In 8, we have 2 in the ones place. In the case of 18, we have 2 in the ones place. Now, for 28 too, we'll have 2 in the ones place. Now, that is a property of cube numbers, right? Now, cube of numbers ending in digit 3 and 7 end in digit 7 and 3 respectively, right? Now, what do we have here? For 3, it will end in 7. Let's see, 13, it's ending in 7. 23, it's ending in 7. Now, for 7, it will end in 3. For 17, it will end in 3. And for 27, it's ending in 3. So, this is the property. This is another property which states that the cubes of the number ending in digits 3 and 7 end in digits 7 and 3 respectively, right? Now, the cubes of negative numbers are negative. Now, how did this happen? First of all, when we were talking about the square of two numbers, let's say we have two negative numbers here, right? So, let's say we have two negative numbers here. We have -1 into -1, right? So, what is negative into negative? So, negative into negative turns out to be a positive number. So, this would give us 1, right? But what if I'm multiplying a negative number 3 times? What will happen? We would have 1 here, but negative into negative becomes positive, and we'll get positive into negative, which is equal to negative. So, this would turn out to be -1. Let's take any number, not just one. We have a negative number n. N is a negative number, right? I'm multiplying negative n into minus n is equal to, we'll get a positive n. Now, if I'm multiplying it 3 times into minus n would give us minus n, right? Now, what if I'm multiplying it for 4 times? We'll have minus n into minus n into minus n into minus n. That would make it, this would be positive, and again this would be positive. So, the result would be positive. Now, what about 5 negative numbers? If we have minus n into minus n into minus n into minus n into minus n, this would give us negative into negative, this becomes positive. Now, negative into negative is again positive, and we have a negative here. So, we have positive into positive, which is a positive, into we have a negative sign. So, this again comes out to be negative n, right? So, if we are multiplying a number by itself, if we are multiplying a negative number by itself, or when we are multiplying two negative numbers, if the number of terms is even, we'll get a positive number, right? I'm taking negative numbers, I'm multiplying the number by itself for 2 times or any even number of times, the number would be positive. And if I'm taking it for the odd number of times, if I'm doing the multiplication odd number of times, that is 1 time, 3 times or 5 times or 7 times, we'll get the answer to be negative. In such way, cubes of negative numbers are negative, right? Now, cube of a number which ends in zeros ends in 3 zeros. How? Now, let's take a number with the least zeros. We should have a 0, but the least amount of 0. That is the 10, right? Now, when we are cubing 10, what happens? We multiply 10 by itself for 3 times. Now, how many zeros do we get for the 10 cube? We get 3 zeros, right? So, cube of a number which ends in 0 ends in 3 zeros, right? Now, if we get a number like 8900, would it be a perfect cube? It wouldn't. Why? Because it ends in 2 zeros, right? Now, there are only 3 numbers whose cube is equal to the number. Which are these numbers? We have 0 cube is equal to 0, which is 0 multiplied any times is 0, right? Now, we have 1. 1 multiplied any times would be 1. Now, minus 1 multiplied even times is odd times is equal to minus 1, the number itself. Now, these are some few properties of cube numbers. Now, we'll move on to cube roots, right? So, what is a cube root? Just like when we talked about square root, when we are saying a number x is x square, right? Now the square of the number x is equal to x square, then the root of x square would become x, right? The same way, if I'm saying the cube of x is equal to x cube, then the cube root of x would be equal to x, right? That is, if we get a perfect cube 8, the cube root is equal to 2, 27 is the cube root of 3, 64 is the cube root of 4, and 125 is the cube root of 5. Now this is the relation between cube root of a number and a number, right? Now let's say here it's given that there is a number 43 here, right? 43 is a number between 27 and 64, right? So the cube root of 43 would exist somewhere in the middle of 3 and 4, right? It would be 3 point something. Now that is one property of cube roots. Now let's see how to find the cube root of a perfect cube by two methods. One, we have prime factorization method, and then we'll move on to the long division method. So first we have to find the cube root of a perfect cube by prime factorization method. So first we'll resolve the given number into prime factors, and then we'll group the factors into the group of 3, right? And then we'll take one factor from each of the group and find the product, and thus we'll find the cube root of a number. So let's say here we have a number 13824. So let's take the cube roots. First of all, we have 3. No, we have 2, right? This is an even number, so we could do it by 2. We have 6 2s are 12, 1 8, we have 9 2s are 18, 1 2s are 2, and 2 2s are 4, right? Again dividing by 2, we have 3 2s are 6. Now 4 2s are 8, 1 balance would be here, and 1 1. We have 5 2s are 10, and 1 balance again, and 6 2s are 12. Now again by 2, we'll get 1 2s are 2, 7 2s are 14, 2 2s are 4, and 8 2s are 16, right? Again by 2, we'll get 8 2s are 16, 1 and 2, we have 6 2s are 12, and 4 2s are 8. Again by 2, we'll get 4 2s are 8, 3 2s are 6, and 2 2s are 4, right? Now we have 432. Let's do it again. We have 2, 2 2s are 4, 1 2s are 2, and 6 2s are 12. Again by 2, we have 1, 0, and 8. Again by 2, we'll get 5 and 4. Again by 2, we'll get 2 2s are 4, and 7 2s are 14. Now what do we do here? Now it's not divisible by 2. We'll check the divisibility by 3. We have 7 plus 2 is equal to 9. So we'll divide it by 3, we'll get 9. Now again dividing by 3, we'll get 3. Again dividing by 3, we'll reach 1, right? Now what is the next step? We actually find the triplets, or group 3 numbers, 3 same numbers together. We have 2, 2, and there's a 2 here, right? This goes to the other team. Now here again we have a triplet, and again we have a triplet. So how many triplets do we have? We have 2 into 2 into 2 into 3, right? Now 4 2s are 8, and 8 3s are 24. So 24 is the answer for 13824. The cube root of 13824 is 24, right? Now cube root of negative numbers. Cube root of a negative number is always a negative number. That's the reason we told about earlier, right? When working with exponents, the only way to get negative result is to raise a negative number to the odd power. So what did I say? Negative numbers multiplied by itself for odd number of times would have a negative result. So if I am raising a negative number to an odd number, let's say 3, or I am raising a negative number to 5, right? Or I am raising a negative number to 7, or any odd number. If I raise a negative number to any odd number, I would get a negative number as a result. Now, cube root of product of numbers and rational numbers. Now, how do we find a into b, the whole cube? What does it mean? We are multiplying a into b 3 times. So we have a into b into a into b into a into b. What does this mean? This is actually a cube into b cube. So a into b the whole cube is equal to a cube into b cube. Now what is cube root of a cube b cube? Cube root of a cube is a and cube root of b cube is b, so we have ab here. Now what is a by b the whole cube? This would be equal to a cube divided by b cube, right? Now let's move on to cube root of a decimal number. Cube root of a decimal number is same as finding the cube root of a whole number. Now, but the difference is the decimal point, right? So the cube root will have 1/3 of the decimal places as the original number. If the original number is something like 0.000008, right? We know that cube root of 8 is equal to 2, right? Now, how many decimal points would have the original decimal number? This would have 1/3 of the decimal places of the original number. That means the original number would have 3 times the decimal places of these number. That is 3 into 3 is 3 times of 1/3 would be like we have to skip 1, 2, 3, 4. No, what would be this? This would be 0.2. Then original number would be 0.2. Why? Cube root of 0.008. There are 3 decimal points and the cube root would have 1/3 of the decimal places. What is 1/3 of 3? It's 1. So we have 1 decimal point in the original number. So it would have 3 times the decimal point for the cube root. Now this is about the chapter cube and cube roots. In this chapter we discussed about what is cube of a number. Then we talked about a perfect cube and we discussed about different cubes of like numbers, whole numbers. Then we went to finding the smallest multiple of the perfect cube, that is we prime factorize, and we will find the numbers which would make a group a triplet. And then we talked about the properties of cube numbers, in which we explained a lot of very important properties. Then we moved on to cube roots, and then we were talking about finding a cube root of a perfect cube by prime factorization method. And then we talked about the cube root of negative numbers and cube root of product of numbers and a rational number. And finally, we concluded with the cube root of a decimal number. I hope this chapter is clear to all of you, and yeah.